Welcome to the Vector launch event. This is the first in a series of webinars that we will be producing throughout the lifespan of the Vector Research Project, which is co-funded by EU Horizons Research and Innovation and UKRI. But I'll leave it to our suite of fantastic speakers today to give you a little bit more information about all of the different details of our research, how our partnership is structured, what our aims and objectives are, and all of the progress we've made to date. So I'm Chris Stockey. I'm a project officer at Satala. We are involved in leading the project impact creation work package and involved in some of the others as well. And I'm joined here today by fantastic members of the consortium. So I have Sarah Gordon, the lead of that impact creation work package, who'll be introducing us to the project and those overall aims and objectives. We have the fantastic Sarah Gleeson, who will be introducing us to all of the wonderful geoscience research that's taking on within the consortium. And we also have Hertje Schutemer, who will be introducing us to all of the brilliant social science research that takes place. And finally, we'll be hearing from the wonderful Maritz Kirch, who will be telling us about how those two different research streams come together and how they're integrated in different data tools from within the partnership and the research contained within Vector. We'll be topping and tailing those fantastic presentations as they flow from one to the other with a Q&A section where we really want to hear from you. We want to hear more about your thoughts on the project, what you'd like to hear more about in the future. If you've got any questions from the brilliant presentations as they come up, drop them into the Q&A and flag them and upvote them as we go. And I'll be pitching them to our wonderful speakers on your behalf. So now that we've all started to enter the room, I can see that there's lots of wonderful people coming from different research institutions, countries. We've got Spain, Potsdam, Bulgaria, Wiltshire in the UK, representing that EU and UKRI linking there. We'll pass over to the fantastic Dr. Sarah Gordon to give us an introduction about the Vector project. Thank you, Vector. Thank you, Sarah.
Brilliant. Thank you very much, Chris. I can be called Vector. We can all be called Vector. In fact, what you will find is that Sarah Gleeson and myself, we often get muddled up because, of course, to be part of the Vector project, it helps to be called Sarah G. But Vector itself, so this is a project that brings together geoscience, social science, and data science to really look at what does responsible exploration look like within the European context. As you can see from the QR code in the middle of your screens, you can go to the website there and find lots more information about what we've already been up to and what we plan on getting up to over the next couple of years. Now, Vector brings together a fantastic group of individuals from across Europe and the UK. We include not only research institutions, all of whom have fantastic individuals undertaking brilliant research, but we also have a great number of industry partners and also consultancies as well, all of whom have got deep experience in really looking at what does exploration and all those aspects concerned with it, what does it look like on the ground, and what are the practicalities with regards to all of these areas. So the motivation behind why Vector has come about as a project. So when we first put together the proposal for Vector, of course, the flavor of the day was thinking about the EU Green Deal and, of course, the resulting sharp increase that we will need with regards to those raw materials. Now, of course, since this proposal was written and, of course, since we instigated the project, we've also had the launch of documents such as the Critical Minerals Act, for example, and other aspects focusing in on raw materials within the European but also global context, which therefore means that making sure we can understand how and where we can source these raw materials from in a responsible manner becomes even more important. We need to understand how to do this practically and in a true manner. So secondly, of course, we need to understand the complex nature with regards to the social, environment, and technical challenges and how they interact. Because, of course, just because a geoscientist, and I'm originally a geologist, just because we might be able to find some lovely juicy rocks in the ground, that doesn't necessarily mean to say that there has to be a mine there. We need to also be able to understand the social context, the environmental context. We need to understand what's going on with regards to, say, infrastructure and different rules and regulations on the surface. So there are lots of different aspects that have to be able to come together in an integrated manner. And that's what Vector really exists to do. So Vector is here to assess these challenges and then say, okay, how can we put humans, so people, in the center of these solutions? Because it's us that have to be able to live with this, both now, but then also into the future. Because what we're trying to do is create a future that we're proud of for our children and everybody who comes after us. So this is all about us trying to understand how can we create that security of supply, but making sure that that security of supply is responsible. So these three different aspects coming together, and you're going to hear a lot more about this from the work package lead, who I'll introduce very, very shortly. So we've got our geoscience vectors, which are going to be focusing in on those minimally disruptive technologies to investigate what is going on or what went on underneath the Earth's surface. So what is going on underneath the surface of the Earth at the moment? Of course, there are many tools and techniques that already exist that, yes, we can make use of, but this particular work package focusing in on the geoscience is really exploring some of those areas to a much greater degree. We've got our social vectors. So what are those different aspects that we need to understand with regards to people? Because, of course, everybody has a slightly different perspective, often based on their own context, on their own experience. What about their values? What about their attitudes? Be that to do with mining or to do with other aspects that may indirectly impact on where people feel these raw materials may or may not or should come from with regards to our energy and our green transition. And then finally, we get to make use of data science and say, how do we integrate all of this together? What can we use with regards to some of those cutting edge digital techniques to say, okay, how do we understand the social science aspects, the geoscience aspects, to point the fingers towards what does responsible exploration, etc., look like? So there are a number of different outputs that we are aiming to create over the course of this project. And again, the work package leads will take you through more of this as we get to them during this afternoon session. We're looking at a variety of different geological models, 2D, 3D, 4D. We've stopped it there. We're not going any further than the 4 dimensions. But this is excellent because it means we can truly understand, again, what might be going on underneath the ground from those different aspects. What we're also going to be looking at here are a range of different techniques, such as passive seismic imaging, and of course, also electrical conductivity as well. So taking some of these techniques to the next level. And we've seen some really exciting data collection going on within some of these areas already. On the social side of things, there are a number of different aspects that we're looking at, such as the social simulator. We've got a range of different education-facing materials, different forms of outreach at different opportunities, as well as continued professional development platforms. So a range of different outputs that are being pulled together on the social side. But the real juice, the real secret and sparkling center of Vector is where we bring it all together. Because again, there is no point in looking for a mine if we're not considering both the geoscience and the social science aspects. We need to be able to bring all of these together. So the real crux of Vector comes when we bring all of these different aspects together, which has already proven to be absolutely fascinating, not least because your stereotypical geoscientist is trained to think in a very different way to your stereotypical social scientists. So already it is really interesting bringing all of these disciplines together to saying, what does that true integration look like when we're trying to think about responsible exploration? So who are we? Well, we're a team of many people from all across Europe, and I'm including UK within that Europe word there, Chris. But so Richard Glacwen, he is our leader with regards to all of this. He's the principal investigator for Vector as a whole, and he's also the lead on the data science work package. So Richard is our go-to person with regards to all things Vector. We also have the fabulous Sarah Gleason, who's leading everything on the geoscience side. We've got Hershey, who is leading everything on the social science side. I'm taking the lead with regards to the impact side of things, and Emily Lewis heads up what is going on the ethics side of Vector. Now, the ethics side of Vector is really very interesting because what we're doing here is making sure that we have a very strong ethics structure with regards to how we are undertaking the project as a whole. Now, ethics means a great many different things to different people, and we will have future webinars focusing in on the ethics side of Vector. And in fact, there was a talk given yesterday morning that we'll post a link to you with regards to what is slightly different with regards to Vector and how we're running the project compared to some other projects that might be out there. We're not saying that other projects are bad in any way. It's just the transparency with regards to the governance of the ethics of the project, which is so important, especially when we're talking about a topic that can be as emotive as mining. So that is the team, and these are the individuals who will be speaking to you over the course of the next half an hour or so. I'm going to leave us again with a QR code in case you want to go to the website. But other than that, I shall pass back to Chris. Thank you very much.
Thank you so much, Sarah. That's a fantastic overview of the Vector project. And hopefully all of our attendees, you can start to get an idea of the scale of the project, the aims and objectives that we're trying to pursue and carry out throughout this time. So now, without further ado, I'm going to hand over to the fantastic Sarah Gleason, as introduced by Sarah, to run us through some of the geoscience research within the project. Over to you, Sarah.
Great, thank you, everybody, and good afternoon. I'm very excited to be here to tell you about some of the geoscience work we are doing and are planning. So my focus of the talk today is going to be more on the philosophy and why we're doing what we're doing rather than any of the first results, because I think we'll have multiple webinars, but it's important to set the scene for what we're up to. Yeah, so this is the Geoscience Parameters and Case Studies Work Package 2. And to start off, I wanted to just take you back to how does a hydrothermal mineral deposit actually form, because we need to understand this a little bit. So these deposits that we're studying were formed hundreds of millions of years ago, and they're basically formed by large volumes of hot water that basically travel in the subsurface, maybe up faults, carrying metals, until they reach a place where the chemistry conditions change and those metals precipitate out as sulfide minerals. So often you may have a rock that looks like this. This is just a boring mudstone. Nobody would get excited about this, but the actual deposit looks like this. And this is a rock that's full of salarite, which is zinc sulfide, and a little bit of pyrite, which is iron sulfide. So when that happens, obviously, the rock is obviously physically changed. The chemistry and the mineralogy of the rock is physically changed. But also the physical properties of the rock is changed. So for example, the density is changed. The ability of this rock to conduct electricity is very different to the other host rocks around the deposit. And the magnetic structure, for example, changes. So often when we think about these deposits and we're trying to think about how might you find them, we bring in this concept of the deposit footprint. And that's the idea that the sulfide minerals are forming in the heart of the system, if you like, but there are much bigger volumes of rock that have seen this hot water passing through it. And around the immediate area of interest, the rock may be visibly altered, but as you go further out from that core zone, you may get invisibly altered host rock, where the rock basically looks the same, but maybe there are subtle changes in chemistry or mineralogy or in the physics that allow you to know you're somewhere near a hydrothermal ore deposit. So how do we then detect these things when they're under the surface? And one of the focuses of Vector is trying to figure out how we find ore deposits that are not exposed at the surface. So how do we know what's happening 200 meters under our feet, for example? Well, the chemistry and the mineralogy sometimes can have a signal that reaches to the surface, but that is not as common as we would like. But this physical properties, this change in physical properties associated with the formation of a sulfide mineral deposit can often be detected by geophysics if the deposit is not too deep. So in other words, you can do a geophysical survey from the surface up here, and maybe you hope that you're going to be able to image that there is some sort of sulfide body in the subsurface. So, and we can do that, and we can build a model to sort of try and predict that. But at the end of the day, the only way we can be really sure of what's beneath our feet at a particular depth is to drill a hole. And for a geologist like me, I'm never happier than when I'm faced with boxes of drill core like this, because it's really giving us an archive of what's going on as we go deeper into the earth. And what's also wonderful is, of course, it's actually a time slice. So we're actually seeing time change in these rocks as we go deeper as well. So we want to drill a hole, but drilling a hole is expensive. So we have to be really smart about where we put our hole and how deep we want to go. And so the question is, if we have a deposit and we drill a hole, how do we know where we are relative to that potential high-grade ore deposit? Particularly if we are to drill a second hole, are there any signals that we find in those rocks to tell us that we're getting closer to the high-grade ore that we really want to find? So this is really trying to understand where we are in this footprint. And that's why we need vectors, because vectors will give us the direction we need to go to find the heart of this ore deposit. And what we're really trying to do is develop or improve geophysical, geochemical, mineralogical vectors that will tell us that we're getting nearer the sulfide mineralization, for example, that we're so interested in. So our approach here is to go to basins in Europe where there are known zones of mineralization, where we can study from the unaltered rocks all the way into the mineralized rocks. And that's what we're doing in Vector. So more specifically, what we want to do is we want to test some of these less invasive geophysical exploration techniques. So these are surveys that can be done on the surface that have a low environmental impact, that could perhaps use seismic waves to try and detect this buried mineralization, or to use the electrical signals of the earth to help detect buried mineralization. And we want to build some models of those. And then we want to combine mineralogical, hyperspectral, petrophysical, and geochemical data from drill holes that our company partners are allowing us to study and sample, to see if we can better identify these vectors to critical raw materials. And Maritz will tell you later, but then one of the things we want to do is take all this fabulous data that we're collecting in the project, as well as data that has previously been collected or by companies, for example, or in old PhD theses or wherever we can get the data. And we're going to transport that into the work package 4, which is the data integration work package. So for this project, we decided to focus on collecting data in 2 areas. So one are the zinc plus other metals sort of systems of the Irish Midlands, and a bit more local to me here in Germany, the Spremberg Graustein deposit, which is a potential copper deposit in Germany. And so the bulk of the work in work package 2 focuses on those 2 areas, and we're collecting new data in those 2 areas. We also have study sites in Jadar in Serbia. There we're not collecting any new data, but our colleagues, partners, Natural History Museum, have an already existing project project there where they have collected a bunch of data, and of course Rio Tinto is the partner there, and they also have a bunch of data. So those data will be included into this project and taken into the data integration work package. So the techniques that we're using are manifold, but basically we're compiling data and making initial geological models based with the help of the companies who have given us access to their drill cores and their logs and their current models. We are basically then going to conduct these passive seismic and magnetotelluric surveys, and that's been led by the geophysicists at the GFZ. We're going to measure these petrophysical properties, things like the magnetism and the ability to conduct electricity on the rocks that's from the drill cores in these study sites. And that's being carried out with our colleagues in Barcelona at CSIC. And then finally, we are looking at quantifying ore and alteration mineralogy using quantitative mineralogical techniques and hyperspectral at the HIS in Freiberg, and also then looking at lithogeochemistry at the GFZ. And by putting all these techniques together on these study sites, we're really hoping to be able to better identify some key vectors to help us figure out how to find mineralization in the subsurface. So what have we been doing so far? Well, there's a lot of data out there, and our industry colleagues already have a lot of data, but that data all needed to be compiled. And that data compilation has been completed in Ireland and Germany. And we've developed the first geological models, completed a passive seismic survey, the magnetotelluric survey, and the hyperspectral scanning has been completed in Ireland on the rocks. And petrophysical, mineralogical, geochemical, basically the lab work is in progress. And now our focus is really moving towards planning our work that's ongoing in Germany, and the mineralogical work is in progress there. And just to show you, this isn't all of the team, but this is a lot of the team. Everybody here is basically contributing. And our colleagues we will have a new postdoc from the Natural History Museum who will be joining us to work on the ADAR data in June. And so we'll have another new face to add to this. But basically, hopefully in our next webinar, I'll be able to show you some of the results of the study so far. And that is it.
Thank you so much, Sarah. That's absolutely brilliant. That's such a great comprehensive overview of all of the wonderful geological research that we're doing within the Vector project. I'm just going to welcome to the stage now and invite them to share their screen, Herchi, who leads on our work within social sciences. Over to you, Herchi.
Thanks very much, Chris. So welcome, everyone. I'm Geert Schuitma. I lead work package 3 on social vectors of primary raw materials, as Sarah already nicely introduced. But obviously, Sarah ended with the faces of everyone involved in this project. I thought I'd start with everyone who's involved. And the one highlight with this group of people is to say that we are often pulled together and called social scientists in general, but clearly, as in every discipline, we have a lot of different varieties in background. So there's psychologists, sociologists, anthropologists, and educational experts, and all these disciplines use different methodologies to collect data and to present their ideas as well. What I'm trying to do in this overview is pull together a lot of these different perspectives and hopefully also do justice to all the different disciplines and methodologies that are used in this group of people. So social sciences, yes, but a lot of varieties within it. So the reason to have a work package on social vectors and the social elements is very often based on these type of pictures. whenever there's a discussion around mining, the extraction industry, there's a tendency that there is general protest or public objections towards these type of activities. You're looking specifically here at, on the left-hand side, at a coal mine that was expanded in Germany in January this year. The threat was that a village locally was going to be demolished on behalf for the expansion. On the right-hand side, Serbia, where lithium has been discussed, work package 2 and Sarah Gleason are working in this area. One thing to notice on these people is it's not local villages or local communities protesting. In Germany, Greta Thunberg was present, the well-known climate activist. In the Serbia picture, you see thousands and thousands of people on the street. This is not a local demonstration anymore. This is actually a much bigger protest against the extraction industry in these specific places. So this is often the reason that is given behind this type of research, but we have to be realistic. And the picture of social vectors and the social sort of responses to mining is much more varied than just these groups of people who are protesting and who are demonstrating. So this is data from a survey study done in Australia a few years ago, and they looked into a little bit more details and the nuances around Australians' attitudes towards mining. And what you actually see is the attitudes towards mining is much more nuanced than simply protesting people on the street. So there was a majority of people thinking that mining would contribute to Australia's economy, is important for their future prosperity, and there was a little bit of mixed feelings about how necessary it is. Now, the reason to put this up is the social vectors, or how can we explain attitudes towards mining, is much more nuanced and much more balanced than simply protesting. So what we are doing in work package 3 is looking into how can we explain sort of the overarching attitudes towards the mining industry. And what that means is, if your research is we need to balance social vectors, or basically determinants of attitudes towards the mining industry. And if you look into the literature, we can see that this balancing act depends on different, what we call beliefs or ideas about the outcomes of the mining industry. So people might focus on the economic outcomes, environmental outcomes, there's trust in actors, perceived risks. These are all vectors that explain how people come to a final overarching idea about the mining industry. Now, what we're researching in one part of this work package is how do people balance these different factors, these different influences or predictors of attitudes. And what we think is that this balancing act very much depends on people's values. So if someone is very strong, high on environmental values, they will make a different balancing act of these vectors as opposed to someone who's strongly focusing on economic values. If someone is very much into social justice, again, the balancing act is probably going to be different, because people's values work as sort of a guiding tool on how to balance and how to prioritize different outcomes of a single object. So in one part of work package 3, we are looking into, can we sort of simulate, this is where the simulator that Sarah Gordon mentioned in the very beginning comes in. Can we simulate different trade-offs and balances that people are looking at? And can we explain, by understanding the values that are driving these outcomes, how people make choices? And if you look at the balancing act, you can think about different groups and different stakeholders that are going through that balancing act. So people in the general public will do a different balancing act than people who are leading in the mining industry or policymakers. And what we're doing in a follow-up study is looking into, okay, how do the different balancing acts and values explain how social vectors are deliberated in these different stakeholders. But if you look at the different stakeholders, you can actually distinguish between different subgroups within these stakeholders. So the general public is not just the general public, but we have local communities, climate activists, teachers, educations, general public. So you can actually distinguish different subgroups within these stakeholders. So if you think about these balancing acts, everyone will have a different sort of outcome of the final opinion attitude around the mining industry. So what we're doing in this part of work package 2 is assess how are the different values distributed across the different stakeholders, and can we find shared values across them? Because that is potentially a place where we can start a conversation. So to that end, we are developing a shared values index, which is hopefully going to illustrate and highlight how these different values can be sort of allocated and mapped across these different stakeholders. And we will use that information to evaluate and assess existing business models in order to see if we can actually make them more aligned with the shared values across the different stakeholder groups. And we'll do the same with UNFC and UNRMS standards, which are categorizations and policy tools to come up with assessment. So we're really trying to look at policy categorizations, business models. Can we align them better with shared values across the different stakeholders? The other thing we're doing is also aim to stimulate critical thinking and a public debate about sort of the need for critical raw materials if the aim is to meet the targets of the Green Deal. And we're particularly focusing here on the general public, teachers and educators, and particular groups in the mining industry. To that end, we are designing and testing public engagement and education materials primarily aimed at stimulating this public debate. A group of us is working on co-designing educational materials with professional learning communities through a research action approach, where they're discussing how might you improve and align and integrate existing current research around these topics in educational materials, so that again, critical thinking and this debate is also put into classrooms and presented to students who will be working in this field later on potentially. And we're working on developing continuing professional development models, which will help industry groups, land use planners, geologists, to think about the differences in values, in assessments, in attitudes across the different stakeholders, and potentially also have a better understanding where different stakeholders are coming from in this debate. So all these elements are really working towards stimulating critical thinking and generating a public debate. So the last thing we're doing is then use some of this data and some of this knowledge and hand it over and work together with Work Package 4. You'll be hearing from them in a minute when I stop. And we're trying to produce data that will be integrated together with the data produced in Work Package 2 in a way that we can actually understand how social vectors and geofactors together can be presented to the industry. So with that, I hand back to Chris. Thank you very much.
Thank you so much. What a fantastic overview of all of the fantastic different social science research streams, or the diversity of them, as you explained to us within Vector. And now I'll pass over, as you wonderfully led to, Maritz Kirsch to tell us about the integration of all of these different research streams. Thank you, Maritz.
Hey, everyone. I'm filling in for Richard Gloagin, who couldn't be here today, presenting Work Package 4, and data integration is its name, but I should be probably renaming that to the juicy, sparkly center, or the crux of the project, as Sarah mentioned. So this is where it all comes together, where we try to integrate the data coming out of Work Package 2, which is the geoscience vector work package, basically, and Work Package 3, the social vectors. And we, as this graphical abstract explains quite nicely, or illustrates quite nicely, that we have that geoscientific sphere, and we try to use machine learning and sophisticated tools to bring it together with that social layer in order to enhance our understanding of exploration and mining projects in Europe. So the objectives, a bit more finer grained here, is first of all the integration of the data coming out of the different work packages on their own. So for example, the geoscientific data, that's for the first objective, to look at rock properties, geophysics, geology, geochemistry, hyperspectral data, etc., and try to make the most of that data by combining it for an enhanced interpretability. We also try to upscale these 3D models that will be created in the process to then understand mineralization processes. So we make these 3D models into 4D models, as you also heard from Sarah already, to understand these processes, but also ensure their transferability from the local scale into sort of a basin-wide scale, and then to be able to transfer that knowledge to other basins worldwide where similar processes are taking place outside of Europe. The third aspect here is the modeling of social vectors. A big part of that will be done in Work Package 3, but we'll sort of take it to the next level and work with the data handed to us by Work Package 3 to assess the shared values, and again, in using a machine learning framework to try to look at the spatial dynamics of these social vectors and try to understand that in context with the prospectivity in a geoscientific sense. And another aspect then in the end is to build these backends. So this is these machine learning models that I've been speaking about, and have a bunch of visualization tools that allow for interaction of stakeholders with the vector data and products. And I'll be explaining all of this in a bit more in illustrations in the coming slides as we go to the first part, which was really the integration of geoscientific data on its own to increase the interpretability of it. And here's an example from what one of our project partners, the CSIC, published as part of another project where we have two data sets that can be very different. One is a P-wave tomography, so coming from a seismic survey. This can be very similar to what we will see in vector as well, since we're dealing with passive seismics as well. And then a data set coming from electrical resistivity tomography. So both of these yield 3D distributions of geophysical parameter in this case. And if you cross-cut, or if you plot these two parameters against each other, you can see that there's a nice cloud of data. And then if we add another layer of data, which is petrophysical data or rock properties, we can actually say what rock type relates to what combination of these parameters. And we can apply a supervised machine learning algorithm, in this case, to try and map the geological units in the subsurface. So that's quite powerful. And you can imagine that the more layers you add to this, the more confidence you will have in the rock types that will be predicted in the subsurface. We then want to take these 3D models and not go back to 2D as it's here, but it's just for presentation purposes. It's better to actually show this in 2D. We want to conduct numerical modeling, and there's a software that's being developed right now by one of our partners, Taranta, that has looked at this in quite a lot of detail in the petroleum system. You can see on the left that they analyze the source system, the migration system, so where oil and gas actually moves and then becomes trapped in a particular horizon where you can then extract it from that reservoir. And the mineral system, is quite similar to that, is in that you have a fertility system. It could be an igneous intrusion, for example, where you have an enrichment of certain elements, our critical raw materials. And then you have a fluid that, for example, is also moving through that fertility system and brings with it these elements of interest, and then deposits them in some certain rock under certain conditions So these get precipitated, and this is where we would look for them, right? So to understand the geoscientific vectors, or the highest grade of that mineral deposit, we need to conduct this numerical modeling to understand where the flow lines go. And you can see here, for example, a fluid flow modeling where we can see that the fluids move along these faults, and this is a stack of different rock types, units, and this is where the fluids would go. So we can track them and say where there would be mineralization in the end. I mentioned the modeling of social vectors, and much of this goes back to work that was done as part of a precursor EU Horizon project called INFACT. And SRK Consulting has been leading these activities and developing a social license to operate index. And it was mentioned by Gertje that this is something that Work Package 3 is considering as well for their shared value index in the end. So it's an enhanced version of this, basically. And it just says that you need to assess certain parameters to assess the likelihood of achieving a social license of mineral exploration and mining projects. And you map the assets basically of a certain population subpopulation, and in order to also identify their needs in these kinds of constellations. And we want to take that to the next level and really regionalize this kind of thinking in order to put it on a map, basically, and be able to consider it as well together with mineral prospectivity. And the way we want to achieve that is use machine learning, but in this case, it's going to be an explainable type of machine learning, because mostly when people hear machine learning, it's mostly a black box. You put something in, some data, and it gives you a prediction, and then you have no idea how the algorithm derived that result. But with explainable machine learning, you actually get an understanding or an explanation for why that prediction was made. So for example, here is an example for different symptoms that somebody may have. So this is away from the mineral context, but there's a migraine, there's temperature, there's weight, there's age. So all these parameters get fed into a model. The model comes up with a prediction because it's pre-trained, it has seen a lot of cases. And the physician, instead of just being puzzled by or accepting that prediction, asks why. And the machine learning algorithm is actually able to say what are the main characteristics of that prediction. So in that case, the migraine is strong and the temperature is high. And another thing that we will use, apart from explainable machine learning, is these counterfactual explanations, which is another way to make machine learning more human-friendly. And it allows users to understand what needs to change in order to achieve a predefined outcome. So we will feed it a lot of socioeconomic information that is publicly available, but that would also be gathered as part of the project. We have a lot of stakeholder views that are coming out of Work Package 3 that will be fed into this model, and the expert knowledge that goes with it. And we would understand in the end through this machine learning model what are the important features in terms of the shared values, and also trying to resolve the stakeholders' concern in certain areas by using this counterfactual explanation model. And it will all feed back into a back end and into a front end in the end that Work Package 5 will also be involved in heavily. And the graphical abstract on the left actually shows that quite nicely, that we have sort of these map layers that we want to have in the end. And on the right, you can see that we will have tools at our disposal that allow interaction with stakeholders as well, to look at 3D models, to comment on 3D models, to really visualize what a mine would look like, both underground or open pit, etc. And it's going to be a variety of tools for stakeholders to engage with the project results. So with that, I hand back to Chris. Thank you.
Thank you so much, Moritz, for walking us through how all of that complicated maths takes place within the Vector project. I'd like to bring all of our speakers back onto our screen, because we've got a number of questions that have been asked to us and you throughout the conference. So First of all, we first had a question submitted to us by Ludovine Wouters. This one's particularly pitched at Sarah Gordon, saying, very inspiring. Sarah, you mentioned that one of the team members is in charge of ethics. Am I right? Could you please elaborate on that?
Yeah, thank you very much, Chris, and thank you, Ludovine, for the question. It was almost if I dangled it out there for everybody. So, as we know, and as very clearly shown by Hershey, mining and minerals and raw materials, especially within the European context, can be incredibly emotive. And there are lots of aspects here where it's very easy to inadvertently be biased in one way or another. So with regards to that, coupled with all of the normal aspects with regards to ethics, with regards to research, etc., this is something here where it was felt that the governance of the project should have a very strong pillar of ethics within it. And actually, Chris, if I can just share a slide here, what we have is the governance structure with regards to Vector as a whole. And what you've got up the left-hand side of this is the executive committee. So many of the people you see on the screen in front of you at the moment. And we also have a fantastic advisory board. But in parallel with this, we have an ethics pillar. And this is there primarily actually to make sure, to keep us right, and make sure we're not inadvertently being biased in a particular way. And the project itself does well and truly say, okay, how do we bring all these aspects together? And what are we finding with regards to it as well? Now, the ethics structure is made up of, so Emily Lewis coordinates this, and she sits within the consortium itself. But then independent of all of the researchers and ourselves, we have an independent ethics advisor who in his day job is a judge, and so therefore brings a very strong pillar of understanding how ethics works to the table. And he is supported by and leads an independent ethics committee that actually at the moment we're in the process of recruiting that independent ethics committee. It's a voluntary committee, but what we're looking for is a broad range of individuals who can represent different aspects of ethics within the project. That includes, for example, machine learning, such as articulated by Moritz, because we can all imagine there are aspects with regards to ethics that we need to be careful of there, through to research ethics, and then the overarching subject matter ethics with regards to raw materials as well. So I'm sure within the chat at the moment, Chris will be posting the link to the page. If there is anybody out there who is interested in sitting on our independent ethics committee, please do feel free to submit your applications, because that committee will be formed very, very shortly in the near future. So the ethics structure, as you could see in that last slide, is there to make sure that the research is indeed neutral with regards to what it is finding, and is very careful with regards to the dissemination of any results, depending on what they might be. I hope that answers your question. Thanks, Chris.
Fantastic answer. Thank you so much, Sarah. You can see that I've posted a link to that page where you can learn a little bit more about what the positions on the Independent Ethics Committee are if you're just interested, or if you're particularly eager, apply for the role yourself. You'll see instructions within that page. So we look forward to hearing from you there. We've also had a question which Hershey has been saying she's particularly excited and interested in, to myself in the background there, which is from Shane Bergin. So I'm going to pitch it to you first and foremost. What do you think will be the social reaction to Work Package 4's modelling of social vectors? Do you think people will trust it?
I think it's a really good question, because I think it's core to get that one right in this project. And it's really, really challenging, which makes it intellectually interesting, but at the same time, obviously, very, very difficult to get right. So I think it is the most challenging question that we have to deal with in this project. So in that sense, it's spot on. And it's certainly something we have worked on when we started writing the proposal. We are continuing to work on making sure that that is that the product we're delivering will be reliable and meaningful at the same time. And it's something that is very, very tricky to get right.
Fantastic. Thank you very much. Would anybody else like to come in on that question? Sarah, I can see you raising your hand there.
Yeah, I think just with regards to this, and this is also because many of us have been in a conference that's all about trust within raw materials over the past week. So it's a genius question, Shane. Thank you. And I think with regards to this, and it'd be interesting to hear Maritz's view as well, one of the outputs from this piece of work is not going to be a map of Europe that says this is a really good place to mine, because the almost the domino effect from that could be incredibly dangerous. And so that is an aspect there, and another reason why we have the ethics committee in place. So depending on what comes from this research, being very, very careful with the dissemination of those results, because the potential cascade of consequences could be very, very dramatic for different individuals. So that's something where there's a huge amount of discussion going on within the group at the moment, saying, okay, what might we find and what might we need to prepare for with regards to that? Maritz, what do you think?
Yeah, I was going to comment as well on, so it's rather than taking that onwards with a social license to operate index, I think we were going to go another way and say we rather focus on shared values and look at how these values may be different in certain parts of the world for different population groups, and not necessarily, like Sarah said, have a map of where it might be acceptable and then just generalize it in that way. And we also need to be very careful for that trust, or to gain that trust in these products, is to be very transparent on how we derive a certain prediction, right? And this is why we are using these kind of machine learning algorithms that have a bit of transparency to them, that are more human friendly, that you can actually get feedback on what parameter it uses to predict certain things.
Brilliant. Thank you so much. I think that's really interesting hearing all of you come in on that, about how it's that collaboration of the different partners involved and the different, that sort of input, sort of showing how we can generate the most beneficial tools that come out of this project, and how we can really provide impetus for different stakeholders. And that kind of brings me on to the other question that we've had sat in the chat posted by Lorna Jones, just asking about how do we foster that collaborative network within the partnership. And I'd like to break that down into two questions, because I'm going to be a bit nosy with it, and say one level, the partnership and consortium as a whole, and maybe then I'd like to talk about within work packages and all of those different institutions involved in that. So I think there's two different lenses to look at that through. So Sarah, because you gave the presentation on the project as a whole, I'm going to come to you about the project. Anybody else please join in, and then we'll talk about work packages.
Okay, I've got to assume that's me, Sarah,
Yes,
with regards
Sarah
to
Gordon.
that, Chris. It's just it's an ongoing, we need to find nicknames for ourselves, don't we, Sarah Gleeson? So I think with regards to collaboration across the entirety of the consortium, so this is something where there are things that we've tried in the last year that have worked, and things that haven't worked. So this is going to be an ever-evolving situation, I think, amongst all of us. So we are undertaking a number of activities. So we're having a get-together fairly shortly, which is going to be fantastic. And a lot of all of us coming together is going to be about actually understanding what one another are doing, and also as well, perhaps learning how to listen to one another. So this is a case, as well as I articulated earlier, if you have been trained as a geoscientist, you've been taught to think in a specific way, which is actually quite different to how a psychologist has been taught to think. Now, we might all be using English as a language to try and communicate, but we know that English in one country is very different to how it is used in another country. So what we have here are the differentiation and the diversity of backgrounds and experiences, but also our professional terminologies, for example, that we use and how we think about things. And so that's something there where, as we go through the course of Vector as a whole, there's going to be a lot of learning between all of the different researchers. So me originally as a geoscientist, I'm learning a huge amount about what Hershey and her team are up to with regards to the collection of different data, and really getting my head around, well, what is meant by a shared value? What does that actually mean? And then what can I do to help enhance all of that? So this is something around, with regards to collaboration across the consortium as a whole, is actually all of us being prepared to be a little bit uncomfortable and say, okay, I'm supposed to be an expert in this area, but actually there's a huge amount of this project that I know nothing about, or very little. However, my perspective with regards to the bit that I know very little about is still very valid. So how do we pull all of that together? So a great question, Lorna. Lots of stuff happening at many different levels within Vector. Will we get it perfectly right by the end of it? Hopefully it will be right-ish, but it's not going to be perfect. Are a whole load of geologists suddenly going to turn into psychologists? No. Well, you never know, actually. They might all decide to go away and do a whole load of training. But this is a case here of hopefully the empathy that we have for one another, and the respect as well with regards to one another's scientific careers, etc., will be such that it means that the consolidation and the integration of all this information will be fantastic. So that's what I'd say about the overall piece, Chris.
Thank you so much, Sarah Gordon. And I just want to come in and touch on that as well before I go into those work packages. I think that that idea of the learning opportunities as well as members of Vector is one of the really exciting things that we all feel on a day-to-day basis when we get to have these get-togethers, is learning about whole new fields. Because ultimately, as researchers, that's one of our favorite pastimes. In fact, it's often our job to learn more. So that's fantastic. Sarah Gleeson, I'd love to ask you and go to you first about collaboration within work packages, and fostering that, and how that sort of process takes place.
So I think I think it is a bit easier within the work package, because at least broadly the people in the work package sort of do speak more or less the same language, right? So everybody in my work package, you know, they're geoscientists or you know, and so broadly the vocabulary is the same. Having said that, it still remains a challenge to you know, to really sort of build a team spirit and a communication network between so many people working in so many different institutes in so many different countries. And I think my experience, this is my first EU grant actually, and my experience here is it requires a lot more meetings and a lot more thought, and a lot more emails than any other project I've ever been involved in, just to make sure that, you know, people really are working together as a group and communicating and moving towards the things that we're going to need. And for us, partially, sometimes it really helps when we can get multiple people actually at the site looking at the rocks together, because then there's a sort of common focus. But I think this open communication, open mind, and being willing to learn from your colleagues is really what this project is all about.
Fantastic. Thank you so much, Sarah Gleeson. And on that note of what this project is all about, I'd like to wrap up this session where we've learned all about the project and heard some of your brilliant questions by going to each panel member and just asking, so what is it that you're most looking forward to in the 2 years of research that we've got left within this project? And I'm going to start with you, Marit.
I have to say that I would finally like to see a real integration of geoscientific and social data. And because we've been trying ever since InFact, which was this EU project that was sort of led to the idea of Vector, I suppose. And it's really about, you know, making people understand that the complexity of a ore deposit is not just the prospectivity of the ore deposit and where the uncertainty as where the highest grade, you know, is located, but it's really the ESG aspects, the environmental, the social, the governance aspects around that. So to visualize that, bring it on a map, and make people realize there's more to it than just prospectivity would be a goal that I would like to see realized as part of this project.
Fantastic. Thanks so much, Marit. Hertje, over to you.
Thanks. So I think the thing I look forward most to is actual data, having data. So we spent the past year a lot of talking, getting staff on board and sort of developing the plans that we put in a proposal. But we're now at the stage where actually collecting data, so which makes it much more concrete. And it's also, it feels like we're working towards results and being able to hand over data to, you know, work package 4 and working together on real things. So that's, I think, the most exciting bit at the moment.
Fantastic. And I'm going to chime in with mine there. My thing I'm looking forward to most is bringing those results to you in these webinars and getting to show off all of the brilliant work going on within Vector. Sarah Gleeson, what are you most looking forward to within the project?
I'm going to give a bit of a selfish answer. I mean, I guess I'm an academic because I'm a lifelong learner. And so for me, actually, the results, particularly from work package 3, for me, because I really don't know much about that stuff. And I feel I need to know more about that since I work on, you know, how ore deposits form. And so for me, this is a wonderful experience and an opportunity to learn new things about shared values across Europe from this sustainability point of view. And so that's really what I'm really hoping to get out of this. It's a selfish answer, but it's a true answer.
It's a fantastic answer. Thank you very much. Sarah Gordon.
Thanks, Chris. So I think all of the above, but then also as well, given the fact that there is so much interest and momentum and need within Europe at the moment through papers like the Critical Raw Materials Act, the Battery Passport that sets targets where a huge volume of materials needs to come from within the European Union, etc. We need to be able to get all of that to work. So a big so what from the project is actually to take these results and take them to those policy makers, those policy setters and regulators and say, okay, this is part of how we're going to make this a reality and how we're going to make sure that the green transition is a just transition and therefore leaves our countries in the most sustainable state for the future. So that's what I'm excited by as well, Chris.
That's absolutely brilliant. I think we're all excited by that too. And on that note, we're going to conclude the Vector launch event, the first in our series of webinars. We've posted QR codes throughout the event, but please do keep in touch with our project through our website, www.vectorproject.eu. I'll be dropping a link to that in the chat in a moment. But come along, sign up to our newsletter and make sure that you're here in our next webinar, which we'll be posting to our YouTube channels that are all linked to our website as well. So if you can't make it, you won't miss out on finding out about our results. Thank you very much for coming, and we look forward to seeing you next time. Bye.